in this one, we're looking at this particular equation, and we want to know the change in energy and the bonding. Well, first of all, let's take a look at this. We know that we have energy coming in, and we know that we're taking this and we're splitting it up into two different elements. So therefore, energy has been absorbed on the reactant side, and we are breaking up the bonds. So therefore, the most likely answer is energy is absorbed as bonds in water are broken. So in this problem, what we're looking at is we're looking at what is the temperature given a solution of NH4Cl at a concentration of 60 grams. So let's take a look. So let's find NH4Cl. Well, NH4Cl is right here. And we want to find it at 60 grams. I'm going to go 60 grams across at NH4. Well, if you look down, you can see that it's around less than 70. So the closest answer we have is 66 degrees Celsius. So in this problem, we're looking at an aqueous solution that has the highest boiling point. Well, we know that when we put salt into water, it increases the temperature of the water. So therefore, we can look at anything that has a salt being added in it. So we know this is not salt, and this is not salt. So CaCl2 and CaCl2 here are both salt being added. And we know that the more we add, the longer it takes for the boiling point to be reached. So therefore, we want to look at the two molarity of calcium chloride. In this problem, what we want to look at is we want to see what will cause the equilibrium to shift for this equation. Well, we know this is a solid reactant and it's producing an aqueous solution. So we can't get rid of the pressure because pressure only works with gas. Then we can look at temperature. Will temperature, as you add it, will cause a shift in? Maybe. What about adding a noble gas? Well, adding a noble gas shouldn't do anything since noble gas should react. So therefore, this should not affect anything. And adding a catalyst. Now we know that when we add a catalyst, it's going to cause no changes, since the catalysts are only added to change or reduce activation energy. It does not affect equilibrium. So we can also eliminate that. And by default, the only thing that's left over is the increase in temperature. So in this problem, we're looking at hydrocarbons that are saturated. And saturated happen to be alkane. And so the formula for alkane is CnH2n plus 2. So we're going to enter in this. We're going to see that we have 2C right here. And so that C is equal to 2. So therefore, H has to equal 2 times 3. Or 2 times 2, sorry, 2 times 2. Plus 2. And so that should give us 6. So 2 carbon, 6 hydrogen. And that does not meet that. The next one is 3 carbon. And then 4 hydrogen. So therefore we can say that that carbon is equal to 2 times 3 plus 2. So that should be 6 and 8. That's way more than what is given on number 2. So we can eliminate that. Number 3, you have C is equal to 4. H is equal to 2 times 4 plus 2. So that is equal to 10. And so right then and there, we know that none of these will meet the saturated definition for hydrocarbon of those 3. Now let's take a look at option number 3, where we have C is equal to 4 and H is equal to 2 times 6 plus 2. So that puts you at 8 plus 2, so that equal to 10. And so the new one should be C4H10. So this right here is asking you to solve for the volume, giving the molarity for an acid and the molarity for a base. We're also given the volume of base. So this definitely is the titration formula as shown here. So in order to do this, all we're doing is we're going to calculate MA times VA is equal to MB times VB. So MA is 0.6 molarity times VA is equal to 0.3 molarity times 100 milliliter. So right then and there, we know VA will be equal to 50 milliliter. So the answer is true. In this one, we are looking to see what is the name given to the item inside the box. Item inside the box has 2 carbon and carbon only, so therefore it will end with YLE, and 2 carbon is for ethyl. In this one, we're looking at a particle diagram, and we want to know what is represented by the particle diagram. Here we have 2 different elements combined together. That is by definition a compound. In this one, we want to take a look at what is an electrolyte. Remember, electrolyte are either things that is an acid, a base, or something unstable. And, well, let's go ahead and eliminate first what is not an electrolyte. Well, electrolyte cannot have a covalent bond because covalent bond do not form ions. So we can eliminate anything that is not an electrolyte. So we can eliminate O2. We're going to eliminate Xe. And we can eliminate C3H8 because that's covalent bond. So the only thing left over is KNO3. This one we're looking at a organic reaction that produces water and carbon dioxide. And so this is a definition. And if you remember your definition, combustion is the one that produces water and carbon dioxide.